So this is the session third for the periodic table. Okay, we can say in session 2, because in the first session what we discussed about the periodic table. Okay, what was some important terminologies related to it. We discussed about what are groups, what are periods, and we discussed about valency, we discussed about atomic size, all of that things we discussed. And apart from that, what we discussed what will happen to certain properties, okay, chemical properties, or we can say like what will the regular trends or periodicity the periodic table will show. Okay, the elements in a periodic table will show, right? We discuss what will happen when to the atomic size when we will go down the group or along the period. We discussed that in the previous session. Okay, now we will be actually doing another properties. We will be discussing other properties as well. Okay, shall we start now?
Yeah.
Okay, so let's start. Let's discuss about, we have discussed atomic size. Now we will be discussing about the metallic character. Okay, so we will be discussing about metallic character.
Yeah.
Okay, now what do I mean by metallic character? Okay, this we have to discuss. All right, so what will be the metallic character when we will go down the group? What will be the metallic character when we will go along the period? Okay, so basically always remember, what are metals? Metals are the good reducing agents, right?
Yeah.
Metals are good reducing agent.
Yeah.
And what reducing agents are? Those which lose electrons to form the positive ions, right? They are the good reducing agents. If you just look at any metal, for example sodium, Na, what is the atomic number of sodium? It is 11. Okay, so just write the electronic configuration. It will be 2 and 8 10, 10 and 1 11. So this 1 can easily get lost, okay, and it can become Na plus, right, to achieve the nearest stable electronic configuration. Yes or no? So
Yes.
what are metals actually? If you look to every metal, the same condition is there. Either they are losing 1 electron to form the positive ion, or the 2 electrons, or the 3 electrons. That's the reason why they are the good reducing agents. Okay, so now what we can say? We can say those elements, I am writing here, very important, those elements which have a very important point, it is tendency, which have a tendency to lose their valence electrons. Okay, valence electrons means electrons which are in the outermost orbits, okay, and form a positive ions, and form a positive ions is called are called as metals. Okay, now we will look what will happen when we will go down the group or along the period. Okay, examples are in front of you. I gave you one example, Na. When Na loses the electron, it becomes what? Na minus electron, it becomes Na plus, right?
Yeah.
Okay, stable electronic configuration of sodium is this. So when it will lose 1 electron, it will become 2 8, right?
Yeah.
Similar is with this magnesium. Magnesium loses 2 electrons to form Mg2 plus, right?
Yeah.
Understood what I am trying to do?
Yeah.
Now there is
Could
one
you
yes,
could you go back to the first page for a second? I just had
yeah,
one
you can.
to that. Could you go? Yeah, thank you. Yeah, okay. Yeah, thank you. Done.
Clear about it?
Yeah.
Okay. Now, remember one thing. Greater is the tendency. I am making you write certain important points first. Greater is the tendency to lose electrons. Okay. More good a metal is. Okay. Stronger is the reducing agent. So greater is the tendency to lose electrons. Greater is the reducing agent. Clear?
Yeah.
Greater is the reducing agent. Okay, or we can say stronger is the reducing agent. Greater means stronger. Clear?
Yeah.
Now, so these are some of the important points. Now let us see what will happen to the metallic character when we will go down the group or along the group. So always remember these are the factors on which the metallic character depends. Okay, so factors on which metallic character depends. Clear?
Yeah.
Metallic character depends. What are those factors? Let us discuss. Number one is the atomic size. Atomic size. Okay. Atomic size. Now always remember when the atomic size will be bigger, okay, the larger will be the more will be the outermost orbits, more will be the number of shells. Okay.
Yeah.
More will be the number of shells and lesser pull will be there. Nuclear pull will be there. So electrons can be removed easily from the valence shell. Okay, and therefore when the atomic size will be greater, which means metallic character will also be greater, right? Clear? So what we can say? Greater is the atomic size. Greater is the atomic size. Are you getting my point?
Yeah.
More will be the number of shells. Yes or no?
Yes.
And the outermost shell will be further from the nucleus, resulting in weak nuclear pull of the electron. Weak nuclear pull of the nucleus to the electrons, and thus electrons can be removed easily. And when electrons can be removed easily, this means more will be the metallic character, right?
Yeah.
The easily you can remove the electron. Okay,
Yeah.
clear about this point? Making the elements more metallic. Clear?
Yeah.
More metallic. So this is atomic size. After that, on second factor, what is the second factor? The nuclear charge. The same nuclear charge. Now what is this nuclear charge? What do I mean by this nuclear charge? Okay, so the larger will be the nuclear charge. Okay, the larger will be the nuclear charge, so greater will be the force exerted by the nucleus on the electrons. Okay, which means
Yeah.
larger the nuclear charge means larger, suppose larger is the atomic number, larger the number of protons are there. Okay, nuclear charge inside the nucleus is there, nucleons are larger. Okay, so more will be the pull exerted to the electrons, right?
Yeah.
By the, okay, and what will happen, this will make it difficult to remove the electrons from the outermost orbit, and therefore metallic nature will decrease. Okay, so this is nuclear
Yeah.
charge. So remember, always remember this important point. Now we can easily solve this mystery. So the greater the nuclear charge, the greater the nuclear charge, okay, the greater is the force exerted by the nucleus on the electrons. Okay,
Yeah.
by the nucleus on the electrons of the outermost orbit. Clear?
Yeah. Yeah.
Okay, and what will happen, this will make making it difficult to remove the electrons from the, making difficult for the electrons to get removed. Clear?
Yeah.
Thus metallic nature decreases with increase in nuclear charge. Clear?
Yeah.
Nature decreases. Okay, so now what will happen when we will go down the group and along the period? Okay, so now this is our second heading, trends in metallic character in a periodic table. Okay, metallic character in a periodic table. Clear?
Yeah.
Should we start? So what will happen when we will go down the group? Okay, so let's go down a group. What we are going to find? So what happens when we go down the group? Tell me. Number of shells increases, right?
Yeah.
Tell me, isn't it? For example, just look at group 1. Lithium, sodium, rubidium, cesium. Okay, so basically then we have francium here as well. Now lithium, it has how much? Atomic number 3, 2 and 1, 2 shells are there. Then 2 and 8, 10, 10 and 1, 11. Okay, atomic number 19 is potassium. Like this, see, number of shells are increasing every time, right?
Yeah.
Which means number of shells are increasing. This means what is happening? This means atomic size is increasing, right? And when the atomic size is increasing, which means the metallic character will, tell me what will happen when atomic size increase? What happens when to the metallic character when atomic size increases? I just told you.
Please. The nuclear pull of the nucleus and the electrons
Yeah, so metallic nature will increase, right?
increase. Yeah.
Yeah, but you can also notice that the nuclear charge is also increasing. See, this was 281, 2881. Nuclear charge is also increasing because atomic number is equals to number of protons equals to number of electrons. Okay, but the effect of atomic size is more. Clear? The effect of an increased atomic size is greater as compared to the increased nuclear charge. Therefore, in total, metallic nature will increase as one will move down the group. Okay.
Yeah.
So I am writing here, when one moves down a group, so what happens? The atomic size increases. The atomic size increases and the nuclear charge also increases. And the nuclear charge also increases. However, always remember one thing, however, the effect of an increased atomic size, the effect of increased atomic size is greater as compared to the increased nuclear charge, is greater as compared to increased nuclear charge. Clear?
Yeah.
And thus what will happen? And thus metallic nature increases. Okay?
Yes.
And thus metallic nature increases. Okay?
Yeah.
Clear? Now, so if we can say our group 1 was this, lithium, sodium, potassium, rubidium, cesium, francium. So we can say that lithium is the least metallic.
Yeah.
Francium, we cannot say francium is the most metallic because it's a radioactive element, so its properties are not known. Okay, it's radioactive. Clear?
Yeah.
Now let's move to group number. So we have done down a group.
Yeah.
Okay, now let's move to across a period. What will happen across the period? Okay, so we can say cesium is also radioactive as well, so we can say rubidium is the most metallic. Okay,
Yeah.
most metallic, because cesium and francium, these are radioactive, so rubidium is the most metallic. I am writing here. Clear?
Yeah.
Now what will happen when we will go across the period? Let's understand this. Across a period or along a period. So can you tell me what happens when we go across a period? Across a period, because atomic number will increase. See,
Yeah.
lithium, atomic number 3 is lithium, then beryllium. Just look here, let me share the screen. See, this is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Atomic number is increasing, so which means when atomic number is increasing, this means what is happening? Nuclear charge is increasing, right? So
Yeah.
so the atomic number 3 is lithium, 4 is beryllium, 5 is boron, 6 is carbon, 7 is nitrogen. Okay, wait a minute. 7 is nitrogen, 8 is oxygen, like this. So what is happening? Atomic number is increasing, which means nuclear charge
Good.
is increasing. Clear?
Yeah.
Is it fine now to you?
Yeah.
So what happens when nuclear charge increases? Tell me.
The metallic character decreases.
Metallic character?
Decreases.
Very good. The metallic character will decrease. Okay? Understood what I'm trying to say?
Yeah.
Okay, so basically what will happen when we'll go across the period? So across the period it will decrease, the metallic nature will decrease across a period from left to right. Okay, so let's
Yeah.
start. For example, lithium, beryllium, boron, carbon, nitrogen, oxygen. Okay, so this lithium and beryllium, okay, these are metallic, but when we will go across the period like this, okay, the metallic nature will decrease. Okay, and
Yeah.
this means that the non-metallic character will increase. You can say opposite as well. Okay, so this will be, lithium will be the most metallic across the period. Okay, across the period
Okay.
lithium is most metallic. Remember this important point, it will be most metallic. This boron, this will be metalloid. And this carbon, nitrogen and oxygen, what it will be? Non-metals. Clear?
Yeah.
This will be non-metals. Okay,
Okay.
clear what I have done?
Yep.
Now let's come to the third period. If I come to the third period, okay, let me come to the third period here. Let me show you. So the third period is sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. So which is the most metallic here? As you can see, sodium, right?
Yeah.
Then we have magnesium, aluminum. So now from here, starting from the silicon, okay, phosphorus, sulfur, chlorine, argon, these will be non-metals. Clear?
Okay.
Understood?
Understood.
So now you can write the examples by yourself. I don't need to write this. I have already written the examples. So across the period, what happens? Across the period, I am writing here, non-metallic character decreases. Across the period, metallic character decreases. And why it decreases? Tell me. Metallic, because
Because the because of the nuclear charge
yeah,
increases.
because nuclear charge, or you can write atomic number as well. Okay, atomic number increases, resulting in greater pull of electrons in the outermost shell by the nucleus. Clear?
Yeah.
Making it difficult, making the removal of electrons difficult. Thus decreasing the metallic character. Okay, this is the full reasoning. Clear about it?
Yeah.
Now after this we have discussed about what will happen down the group and across the period. Okay, now we will be discussing non-metallic character. So we discussed about the metallic character. Now let's discuss about the non-metallic character. Now what is this non-metallic character? Non-metals are good oxidizing agents, right? They were good reducing agents. Non-metals will be what? They will be good oxidizing agents, right? Why?
Yeah.
Because they can gain electrons. For example, let me give you one example. For example, chlorine. Okay, if you look at chlorine, atomic number is 17, 2 and 8, 10, 10 and 7, 17. Now it can easily gain an electron from outside, right? One electron to complete its octet, and it will become Cl minus because it has gained one electron, right? Yes or no?
Yeah.
So how I can define the non-metallic character? Those elements, just write here with me, those elements which have a tendency to gain electrons in order to attain octet in their orbit, outermost orbit, are considered as non-metals. Okay, are considered as non-metals. I hope this is clear to you.
Yeah.
Okay, these are considered as non-metals. Now non-metals will usually have 5, 6 or 7 electrons in their outermost shell. Okay, for example, we just look at the example of the chlorine. Okay, now, so if you look at the example of chlorine, what happened to the chlorine? Chlorine gained 1 electron, Cl plus E, and it became Cl minus. Yes or no?
Yeah.
Earlier it was 287. Then it gained 1 electron and it became 288. Right?
Yeah.
Okay, then similar is with oxygen. Oxygen is how much? Atomic number 8 is oxygen. It gains 2 electrons to achieve the nearest electronic configuration, 2 and 6.
Yeah.
Right? And after attaining 2 electrons, it will become O2 minus. Okay, and the nearest atomic configuration will be, electronic configuration will be 2,8. Clear? This is non-metallic character. Also, non-metallic character depends upon the atomic size and the nuclear charge. Okay, so obviously what will happen to the atomic size? Okay, when atomic size will increase, so smaller is the atomic size, greater will be the nuclear pull, and the more will be the tendency to gain the electrons. Right or not? Opposite of the metallic character I am talking about. Non-metal is the opposite of a metal, right? So the properties will also become opposite. Okay? So factors on which non-metallic character depends. Non-metallic character depends. So what are the factors? Same factors. What? Number 1, atomic size. Atomic size. Reasoning you can write by yourself now. And second one is the nuclear charge. Okay. But what used to happen? What used to happen in the metals? In the metals, when atomic size used to increase, metallic character also increases. Yes or no? Because easily the outermost orbit could be removed. The outermost electron could be removed from the outermost orbit, right?
Yeah.
But what will happen in this? So when the atomic size will be small, more will be the non-metallic character. Okay, smaller the atomic size, more will be the non-metallic character. Clear? Why? Because the nuclear pull will be more. Okay, and one electron can easily jump from the outermost shell to the inner shell and complete the octet. Okay, clear? That is atomic size. Now What about the nuclear charge? Remember, the greater the nuclear charge, the greater is the tendency to gain electrons. Okay, more will be the nuclear charge. There used to be opposite in the metallic character. Okay, which means the properties will also reverse. So what used to happen when we used to go down the group in the periodic table in case of metals, metallic character, when we are talking about the metallic character, what used to happen when we used to go down the group? Tell me.
When you went down the group, the atomic size increased.
The atomic size increased,
And
very good. And then what will happen?
the charge also increased, so then the metallic character increased.
Yeah, metallic character is increased, but the effect of the atomic size is more, due to which metallic character increases. But what about the nuclear charge? Nuclear charge, when the nuclear charge increase, metallic character will decrease. I am talking in case of the metallic character, but there this will be opposite in case of non-metallic character. Clear?
Okay.
So what will happen to the non-metallic character when we will go down the group?
It will.
Let me write here so that you can better understand trends in periodic table. Non-metallic character I am talking about. Okay, non-metallic character. Clear?
Yeah.
Non-metallic character. So basically what will happen to the non-metallic character? Obviously when we will go down the group, let's discuss about when we go down the group. So down a group, what happens? When we will go down, shells will increase, number of shells will increase, right? And when the atomic size increases, what will happen? New shells will be there. Okay,
Yeah.
nuclear charge will also increase, but the atomic, you know what will happen? Atomic size effect will be greater, therefore non-metallic nature will decrease. Non-metallic nature will decrease. We can say metallic character will increase. We can also say the opposite. Right or wrong?
Right.
So non-metallic nature decreases. Why? Because on going down a group, both atomic size and nuclear charge, same reasoning will be there. Nuclear charge increases, but the effect of atomic size is more. Clear?
Yeah.
More, due to which electrons can easily be removed from the outermost orbit thereby decreasing non-metallic character. Remember this, and a metallic character will increase. Okay.
Yeah.
Now what about this is for the ongoing down the group. Okay, when we go across the period, when we go across the period, what happens when we go across the period? Tell me.
The atomic number and the nuclear charge increases.
Very good.
So then
Non-metallic character will
Yes.
also increase, obviously, right?
Yeah.
Okay, because the tendency to gain electron will be increased due to increase in the nuclear pull, okay, across the period. So therefore we can say that, for example, we have this sodium, then we have this magnesium, aluminium, silicon. Okay, this is 11, 12, 13, 14, silicon, phosphorus, sulfur, chlorine. 15 is phosphorus, 16 is sulfur, 17 is chlorine. So now which will be the non-metal here? Obviously chlorine will be the non-metal here. It will be having the largest non-metallic character. Okay,
Yeah.
like this. And this sodium will be the minimum non-metallic character. Earlier sodium basically used to have, if you look here in the previous table when we were talking about the metallic character, okay, so sodium used to have the highest metallic character, right?
Yeah.
So this is how it goes. Clear? Okay, so we can say when we go like this, non-metallic character will decrease, non-metallic character will increases, or we can say opposite as well, metallic character decreases. Clear? When we are going across the period. Any problem so far?
No.
Reasoning will be same. Okay, you can check out from the book, because if I will write everything then a lot of time will be wasted. Okay, clear?
Yeah.
Now let's talk about another one, chemical reactivity. What do I mean by chemical reactivity? Basically, which means how the elements are actually reactive to each other. Okay, so it basically depends upon their tendency to lose or gain the electrons. Okay, so greater is the tendency to
Yeah.
lose electrons, greater is the reactivity in case of metals, and greater is the tendency to gain electrons, greater is the reactivity in terms of non-metals. Okay, so reactivity
Yeah.
in both metals and non-metals criteria is different for reactivity. If the metal can easily lose the electron, then it is highly reactive. Okay, and if the non-metal can easily gain the electron, it is more reactive. Okay,
Yeah.
clear about this? So let's discuss then. So now what will happen when we will move across the period? So chemical reactivity we were discussing. So two important points here. Okay, so for metals, two important points. Okay, for metals, greater the tendency to lose electrons, greater the tendency to lose electrons, clear? Greater is the tendency to lose electrons, greater is the reactivity. Whereas for non-metals, what will happen? Greater is the tendency to gain electrons, tendency to gain electrons, greater will be the reactivity. Clear about this?
Yeah.
Two important points. Okay, now let's see the trends in chemical reactivity across in the periodic table. So trends in chemical reactivity. friends in chemical reactivity. So what is going to happen? Okay, when we will moving down a group. Okay, when we will be moving down a group. Okay, so basically when we go down the group, so what happens? When we go, we just see the metallic character and the non-metallic character. When we go down the group, so electrons can be easily removed, right? Because number of shells increases. Are you understanding my point? Number of shells are increasing, due to which electrons can easily be removed and metallic character increases, right? Metallic character increases when we go down the group. Okay, therefore what will happen? This means chemical reactivity of metals will increase. Okay, chemical reactivity of metals will increase. Okay, whereas chemical reactivity of non-metals will decrease. Understood?
Yeah.
What I am trying to say? See,
Yeah.
I am telling you with the help of an example. For example, this is lithium, sodium, potassium, rubidium, cesium and francium. This is group 1. Okay. Sodium, how many shells it has? 2 and 8, 10, 10 and 1, 11. Potassium, 2 and 8, 10, 10 and 8, 18 and 1, 19. Like this. This is only 2 and 1. So 2 shells, 3 shells, 4 shells and so on. So basically how many shells are there? Shells are increasing every time. Okay. This means that it is more easy to remove this outermost electron because the nuclear pull will be really very less, and whenever the electrons can easily be removed, this means that the metallic nature will increase, metallic character will increase. Therefore when easily the electron is being removed, this means that more good or active the metal is. Okay, we just discussed. See, for metals, greater the tendency to lose electrons, greater is the reactivity. Look here, I have made you written. So here you can see that for this one, for this potassium, as you can see, and for this rubidium as well, the greater will be the tendency to lose the electron. Therefore chemical reactivity down the group for metals will be larger. Okay, chemical reactivity down the group for metals will be larger. Okay, whereas chemical reactivity what will happen to the chemical reactivity? Tell me. What will happen to the chemical reactivity?
It will decrease.
Decreases. Chemical reactivity decreases. Very good. Because these are opposite. On going down a group. Any problem?
No.
Understood? What is the link here?
Yeah.
So this is what happens. Now let's talk about across the period. Across the period. Now let me give you one more example of down the group. Okay, for example, fluorine, chlorine, bromine and iodine. Fluorine, chlorine, these are halogens, right? Halogen group.
Yeah.
Okay, so on going down the group, what will happen? Metallic, non-metallic character will decrease, right? Non-metallic character will decrease. Metallic chemical reactivity for metals will increase, whereas chemical reactivity for non-metals will decrease, which means fluorine is the non-metal, okay, which is most reactive.
Yeah.
Okay, most reactive non-metal. Clear? Fluorine is the most reactive non-metal. Understood now what I am trying to say?
Yeah.
Are you not getting confused?
I know.
Are you understanding everything or not?
I am.
Okay. Now let's talk about, since down a group we have discussed, now let's talk about across the period. Okay. So what happens when we go across the period from left to right in a period? Okay.
Yep.
There, this is opposite actually. Okay. So on moving from left to right, I am writing this statement, very important statement. On moving from left to right across the period, very important statement. There is left to right, okay, in a period.
Yeah.
What happens? The chemical reactivity of element, the chemical reactivity of element first increases and then decreases, and then decreases. What do I mean by this? Basically, for example, group 1 elements can lose electrons easily as compared to group 2, right? As compared, because nuclear charge will be increasing. Okay, when we go to the, just look at this periodic table first. So this is group 1. Okay, group 1.
Yeah.
Then after that we have group 2. Okay, so this group 1, the number of shells are increasing in group 1, but here the nuclear charge is increasing. So this means that group 1 can easily lose the electrons, whereas group 2 cannot, as compared to the group 1 element, right? Am I right or not?
Yeah.
Similarly, group 2 elements can also lose electrons easily. Okay, yes
Yeah.
or no? Compared to the group
Yes.
13, right? This is group 13. Don't count these groups, this one. We will directly start from group 13, right?
Yeah.
Okay, so basically what will happen? So tendency to lose electrons will decrease. Okay, tendency to lose electrons will decrease when we will go across the period, right? Because nuclear charge is increasing, tendency to lose electrons will decrease. Okay, and when tendency to lose electrons decreases, which means tendency to gain electrons increases, and non-metallic character will increase. Okay,
Yeah.
hence reactivity will increase. Okay, non-metallic character increases. I am writing here, that is non-metallic character will increase, and metallic character will decrease. Metallic character will decrease because of increase in nuclear charge. Okay, now let me give you one example. For example, let us take third period: sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine. Okay, 11, 12, 13, 14, 15, 16 and 17. Now just look here, every time atomic number is increasing, yes or no?
Yeah.
So atomic number is increasing, which means tendency to gain electrons is also increasing, right? So chlorine is the most reactive non-metal here. Okay, in the third period, most reactive non-metal, and this will be Na. What will happen? It will be the most reactive non-metal and least reactive metal. Clear? Least reactive metal. Okay, you can write the opposite as well, or you can say this is what Na is the most reactive metal, right?
Yeah.
Most reactive metal here. Understood what I am trying to say?
Yeah.
Okay, now when I will go like this, the non-metallic character will increase and this will become the most metallic, and when I will go from here to here, here the metallic character will increase. That is the reason why this is most reactive metal. Clear? Understood?
Yeah.
Now let's talk about the melting and boiling point. Okay, melting and boiling point. Now what do I mean by melting and boiling point basically? Okay, so basically it is the minimum temperature at which the metal starts to melt. That is the melting point. Okay, and boiling point is basically when the liquid starts to actually vaporize at that temperature, right? That is the boiling point. Okay.
Yeah.
Now, so melting and boiling points of metals will decrease on going down the group. Okay, we are first talking about down the group. So down a group, just write this, down a group, what is going to happen? Down a group, melting and boiling point of metals will decrease. For melting point I am writing MP and BP. Clear? Melting and boiling points of metals decreases. Okay, on going down a group. Clear? On going down a group. Okay, for example, lithium has the highest melting and boiling point, then sodium will have the in between, and potassium will be least. Okay, it will be decreasing. So lithium, potassium, and then we have sodium. So now melting point and boiling point will decrease. Clear?
Yeah.
Like this. So down the group when we will go like this, but opposite will happen. Okay, on going down the group for non-metals. Okay, so the melting and boiling point of non-metals will increase. Okay, MP and BP of non-metals increases on going down a group. Clear? For example, let me give you one example. Fluorine, chlorine, bromine, iodine. Just go to the halogen groups. So this is fluorine, chlorine, bromine, iodine. So when we will go down the group, clear? What is going to happen? Tell me. Melting point and boiling point will increase. There used to decrease, here it will increase, which means iodine will have the largest, right?
Yeah.
Yes. So in book you can see the figure as well. There the melting point and boiling points are given. Okay.
Yeah.
Now let's talk about across a period. What happens when we go across a period? So while we move across a period, what happens when we go across a period? Nuclear charge increases. Okay. And non-metallic character increases. And when non-metallic character will increase, so for the non-metals, melting and boiling point was how much? So fluorine. So when we go down the group, basically non-metallic character decreases, right? Whereas the stronger the non-metal is, Remember, stronger the non-metal is, less will be its boiling point. Clear?
Yeah.
Okay, so what will happen when we'll move across a period left to right? Melting point and boiling point will go up to group 14. It will increase, and after that it will decrease.
Yeah.
Okay, after
Okay.
that it will decrease. There is a reason for its decrease, let me tell you, because density of elements also increases. Okay, and after that slight decrease you can see there. Slight decrease will be noticed there. That's why. Okay, understood what I'm trying to say?
Yeah.
So across a period, what will happen when you will go across the period? So suppose this is sodium, magnesium, aluminium, silicon, phosphorus and carbon. So melting point is given. For example, 98 degrees centigrade, this is the melting point for this sodium. Then we have 650 degrees Celsius. Then we have,
Yeah.
for aluminium it is 660, for silicon it is 1410. It goes like this. You can see after that what happened, it again become 44, it became least, and then again it started increasing.
Yeah.
115.2. So it was 98, 650, 660. Again it increased to high. Then after that 444.2, 115.2. So what is happening here? Okay, so first it increased like this. Then there was a decrease here. Okay,
Yeah.
because just come to group 14 here. Let me show you this one. This is group 14. Carbon,
Yeah.
from carbon it is group 14.
Correct.
Now look carbon here. From carbon 115, right? Even this started from group 14 as well, group 13 as well. See.
Yeah.
Okay, just look here. This is group 14. What is happening? See,
Yeah.
this is silicon, phosphorus. We are taking silicon and phosphorus here. So silicon is here, phosphorus is here. So just look at the silicon first. Silicon is 1410. After that, what happened?
Okay.
Phosphorus decreased, right?
Yeah. Oh yeah. Okay.
Phosphorus decreased. So what will happen? First it will increase, and then there will be slight decrease. Clear?
Okay. Yeah.
Across a period. Melting point and boiling point. Melting point and boiling point usually increases up to group 14. Clear? Clear? Up to group 14 it will increase, we just noticed, and then it will decrease. Yes or no?
Yeah. Yes.
Decreases. Now let's talk about the density. So density, the same condition is with the density as well. So we have completed this chapter 90%. Only ionization enthalpy or ionization potential is remaining, and in the next class we will complete this remaining chapter. Okay, and we will start new chapter. All right.
Okay.
Yeah, if this is just 15 minutes or are remaining, that's it. 15 minutes more. After that, this will be completed. Okay.
Cool. Yeah.
Clear?
Thank
we
you.
will start the new
Yeah.
chapter. Don't forget to revise it, what I have actually made you written, and then afterwards I will give you some important questions. Okay.
Okay.
And on the next day, which means on this coming Wednesday, we will start new chapter for physics, work, energy and power. Okay.
Yeah.
Thank you then. Have a nice day.
Thank you.